Now I would like to start the program for the afternoon. The speaker is Daisuke Yamazaki. He is invited as a guest speaker for 11th Ruby World Conference. Mr. Yamazaki started his career at Yahoo and then started up a company named Scale Out, the company providing the advertisement distribution system. As CEO, he developed a DSP and SSP. And then in 2015, Scale Out became a Supership company through merger and acquisition. He assumed the position of CTO. And he develops and built a system with over 1 trillion a month access. And also he promotes the development and the building of infrastructure. The title is a distribution of the super large amount of data through Ruby. I'm Yamazaki from Supership. Thank you very much. I'm going to talk about the large amount of data transmission, distribution via Ruby. I was wondering what kind of title would be appropriate. Last year at the Ruby World Conference, Toyota Data, Mr. Furuhashi, he's also an engineer. He talked about the utilization of the data, treasure data, using Ruby. That is the company centered around Ruby. My company is also as well, and he's from Tsukuba University as myself. Matsuda-san is also from Tsukuba. And in addition to the Tsukuba, here we are at Matsue, where the rural area is also working very hard. Now the company is a Supership. I'm a CTO. As has been introduced earlier, in 2006 I started up Scale Out after leaving Yahoo, and it was merged and acquired and became one of the group companies of KDDI. And also after and at 2015 it started once again as a Supership. I'm a CTO at the company. I'd like to talk about 30 minutes. I'd like to introduce my company and also how I was able to establish the large amount of data distribution system with Ruby, and how I have confronted the business needs with Ruby. As Matsumoto-san has mentioned, this is one of those languages in this kind of application, but the establishment of a large amount of data distribution system is also possible with Ruby. I'll talk about this later, but after the acquisition of the company, for instance, you need to confront against a large company, and how I was able to cope with large needs on the part of the large company. I'd like to talk about that. And one of the subsidiary of a Supership holding with equity from KDDI, the company was established in November 2015, and a strategic subsidiary of KDDI. We promote a wide-ranging of businesses. This is a holding company, and the internet-oriented company is also working very hard. The Scale Out platform is provided. This is a distribution system, largest in the country, and there are 450 accesses on the surface, but the distribution transaction of the advertisement, that is 500 billion per month. So total will be 1 trillion. The largest advertisement distribution system in Japan. This is sales turnover. In 2017, the sale was 25.4 billion, and from 2015, the company has grown every year. This is the profit. The operating profit started low and now 1.39 billion. and continue to grow this way. There are some big figures and important people here, so I'd like to demonstrate that the Ruby can make a profit like this. And the scale out, as I mentioned earlier, can handle the access of 1 trillion per month. Originally, the advertisement distribution system was scarce in Japan in those days, casually at low cost, not only in Japan but globally. The online the advertisement distribution management system was needed. SSP, DSP, technical terms, and that is the requirements of the advertisement business. And also we can respond to any distribution needs of the digital advertisement. And everything is very important. I will explain this later. But in the internet business, not just the advertisement business, but actually the future prospects of the business is unpredictable. So with Ruby now it's possible to respond to any kind of development. That is quite important and essential. Ruby and distribution system. The configuration of the distribution system is a 3-tier. In the middle, and this is the data of the advertisement, and this is the distribution the monitoring system, and this is a C++ is used for writing this, and this is a general configuration. Now here, the user access account for hundreds of a billion. Rather difficult to support this, therefore C++ is used. However, on the other hand, here, this is a C++ server, but underneath there's a database, unique, singular database, and you have to do the reading and writing at high speed, super high speed, and the writing program is almost written in Ruby, this administration program group. The structure of this group of programs start from database, and then the script of Ruby is generated and then given to ad server for implementation. This is rewriting the shared memory. I'm talking about this DSL. And written in Ruby. The codes are written in this way and implemented at ad server. When it is implemented, then it is rewritten, and the advertisement item will change at high speed. Why did I write in Ruby? This is a database. Data structure can be replenished. But the interoperability of the data can be secured with Ruby. That is quite important. For instance, if you write memory with C++, there is a problem of the memory mapping and data layout. Therefore, every time of the version up, then you need to write a program. It is too late. You cannot catch up at all. So data interoperability will be written in Ruby, and interoperability is secured and maintained with the Ruby language. Therefore, horizontally, data operability can be maintained. DSL is the same, so even with a higher version, it is possible to follow. Now, DSS is a quite good and a happy solution with Ruby. Ruby is a happy solution because you can combine with the meta programming. You can do whatever you want to do. The new function is added and put into a class, and when the class exists, you can implement that particular new function. So it's a free, and the ad distribution system cannot be replaced by the new one. This is the distribution side. For the aggregation side, Now, on the side of the distribution server, the primary process is done, and then after that, the primary aggregation is done with a log format device to better speed, and this is distributed, and therefore everything can be done on Ruby. Now, this aggregation system, the overview is like this. This is the totality of the distribution system, and primarily the aggregation is performed and then collected at one place and then loaded up to the advertisement item data. Now, distribution server, the log is about 100 mega or so, and primarily the processing is done to compress to 100K, and the speed is not sufficient, therefore C++ is used for extension. And then after collection of the primary process data, then merge with the Ruby and load it. This is with Ruby. The 100K size file and 5,000 file will be loaded, and Ruby is fast enough. This is a summary of the scalability, so we can manage with Ruby. If the speed is not sufficient, then we would add C++ extension with a C++ server, but mostly we can do with Ruby. You can divide the responsibility. At this moment, we have 1 trillion access, and as far as we add the server, we can cope with that. Moving on to the Ruby and the business. Now, I started up the company, acquired by the huge company, KDDI. We are working in a giant. So that's what I want to say. Now, this is so many technical terms and different terms. Now, the advertisement distribution system is made up of these PMP. You might not have heard about it. These are the kind of a business we do. Please look at this with a bird's eye view. It's so complicated. This chart shows each one of those the data pieces, the situation surrounding the advertisement industry. You see a tiny one that is that represents one company. So 5,000 company, as you see, and these are 5,000 companies worldwide. What I would like to say is that these are some companies are competing in the several trillion yen worth of advertisement industry market. As you see, at a glance, 1 decade ago, there used to be 300. Now we have 5,000 companies. So advertising business is large enough in this kind of a market. So 5,000. And the company, we have to be competitive. And we were acquired and work together with a large company, KDDI. Usually, the compatibility between large company and a venture company, small company, or even with a government, the large organization, it is a kind of the good combination of the agility of a venture company and the huge resource of a large company. But in reality, because of inertia in a large company, decision making is so slow, and the person in charge can make a quicker decision. So large company is not speedy. On the other hand, when they decide to do something, they start to move immediately, and the speed is much faster. And the KDDI is large with a lot of resource, and they have a connection with other large organizations, so they get a huge deal by tomorrow, by a week from now. please accommodate 30 million users, for instance. That is a huge business size. So when it comes to venture, I'm sorry, we don't have such a huge system. So now the large companies are slow and we cannot work effectively. But actually, when it comes to the huge company, they are powerful with the resource. And once they start to move, they move quickly. And that's why they are slow in the beginning. And venture cannot handle this huge needs posed by the large company. As I mentioned before, we have to fight. So we need the power of the large organization. Before I started up the company, just before starting up the company, I was expecting to have this kind of involvement. I used to have a longer hair actually. And after thinking hard, I came to this kind of a stupid conclusion. Super scalability, super flexibility, super no downtime, and a super system. This would make us respond to any request from the large company.
そこでRubyがすごい
I want to create that kind of system.
考えたこととして、
When thinking about implementation, in order to create that super wonderful system, I'm not a very good programmer. So if I write a program as usual, it would be the product as usual.
成功している OSS とかそのシステムを参考にしようと思ったんですね。
So if I refer to the OSS or system which are successful, I may be able to have some wisdom. So I try to look at that product which has been successful, including OSS and systems. What I refer to is the OSS which has been long-lasting. And I try to analyze the reason why they can continue growing for an extended period of time. Then I may be able to find some tips for the success, and I may be able to get the philosophy of those old OSS. There are other OSS. These OSS has been developed to solve the current problems. There are some reasons behind the development of new OSS. They may be developed because the developer would like to solve the problems. And if we look at the difference between the old and new OSS, we may be able to reach some idea. These are the OSSs which I have looked at. RAID and QMail, because I started the company years ago, and Emacs and Lisp, and Ruby and Rails, of course. RAID is our compilation of the hard disks so that they may construct robust disks. So even if the components, which are the constructs of the system, are unstable, still we don't have to give up the stability of the whole systems. Linux in the past was not very stable, but load balance is placed on top of it to improve the balance. So even if the component is unstable, it doesn't mean that the whole system is unstable. The QMail is another system I refer to. Now it is called postfix. And it is important that multiple programs should not excessively rely on each other. And these multiple programs should be constructing a system in a coordinated manner. Emacs, there is drawing engines plus Emacs Lisp. And Firefox is the same. They have the drawing engine as a browser, and it is combined with JavaScript. This is how the system is constructed. So these two systems have the characteristics. There is a language incorporated, and the function can be added. This is the citing from Paul Graham from Yahoo Sales. He is one of the very famous persons, and he talked about the things in the article called on Lisp. So if it is okay, the programmer has to supply scalable software. Why Ruby and Rails are selected? When I started my company in 2006, I used Rails, and it was very good. And also another requirement for the AD system, we have to be a super scalability, super flexibility, and super robustness. And C, I don't want to have a very frequent updating. So we would like to I would like to make a system so that we may be able to have intentional adding of the functions. And I use add server. I have business logics registered in the management database. Then it is uploaded to the system. This is the JavaScript, not Ruby, and there are engines for JavaScript. Since it is JavaScript, we can do whatever we like to do. And the JavaScript generation was made with Ruby. And it is a super robust system. However, it is super flexible. This is very important. Add server should be robust. Then the business logics should be described with JavaScript. And the description is to be generated with Ruby. And Ruby is flexible, so there is a very good synergy of the robust system with a very flexible system. And there is Y Combinator programs. Do you know that? I have described it a bit. Beating the average. This is the store editor, which is the basis of Yahoo editor. And this is a person who got involved in the venture capital. And they tried to take a risk. And beating the average is the program they used. And Risp is a very robust language, and they tried to beat others with Risp. Then I read this article. Then the Ruby, I got to know the Rubies, and I found that Ruby was great. And Ruby and Rails, the program could fight against the rival with Lisps. However, it means that they have Ruby and Rails. He was in Yahoo. I don't know whether it is true or not, but for me, the Lisp is Ruby, and I may be able to continue fighting the soft flexibility of the Ruby and the capacity, large capacity. I may have been failed in the middle. So my encounter to Ruby was very fortunate. It was very fortunate for me to get to know Ruby. And in the field of business, it is really a tough world to fight. We need to have some armamentariums. And the armamentariums we have should not be the ones which other people have. If you have an opportunity to fight, you have to have an armamentarium. to fight. So it is a matter of fact to construct the super large system using Ruby, and you can make it. And also the entrepreneurship is not something of the foreign world. We can start our own business. We can be an entrepreneur. Though it is very hard. And I'm an engineer, and I was an engineer, and I am an engineer. Programming gives engineer power, and with this power, we can change the world. This is something I want you to know. Thank you very much for your kind attention.
山崎様ありがとうございます。
Thank you very much, Mr. Yamazaki. Now we would like to entertain questions from the floor. Any questions from the floor? Yes, yes, please. The person in the front row. Thank you. Thank you very much for your talk. My question is the following. In your talk, you talked about the trillion access number of trillion. A trillion access to your system. What are the scripts coming out from that access or the programming language? Do you make it visible to us? Then if we put it into the paper-based materials, how big is the information? So you want to know a trillion access is converted into how many pages of a newspaper, right? Yes, it is very rough calculation. Japanese, in Japan, Yahoo and Google have 20 trillion accesses, and the internet ad budget, there is a 6 trillion yen of ad access, and internet occupies 1/6 of it. Then it might be equivalent to 120 trillion access to the paper. So the internet access can be counted as 6 access to the paper. So 1 trillion access. So it is very difficult to calculate how many paper or how many pages in paper is equivalent to 1 trillion access on the internet, right? Yes, the time to make an access to the internet or paper is limitless. So if we calculate in the formula I mentioned, it would be 120 trillion accesses. Thank you. Any other questions? No? Yes, please. Yes, please. Thank you very much for your talk. JavaScript was generated with Ruby. There are many things which can combine with JavaScript now, but it was 10 years ago when you started your business. You made that JavaScript code with Ruby. Is it what you did? Yes. So you made some sentences or structures with Ruby to fit the JavaScript. A little bit more casual, more rough. There was a template. So you based upon the ERBs and you made the pattern and you embedded it. Oh, yes. But there is some extension to it. And that's something we did. This is an advertisement. So this is DSL and JavaScript generation using the logics there. Oh, I see. Thank you. Ruby is useful. Oh, I see. Thank you. So that's the end of the questions, and we would like to move on. And if you have further questions, please ask him in person. And what is the origin of your company? You may think of ship, but ship is a leadership ship. So ship is a friendship and leadership. It's a great person. So it is nothing to do with the boats. So super great persons or super great group. There are students here, and entrepreneurship is another dream for the students. Thank you very much, Mr. Yamazaki. We would like to give him a round of big applause. Thank you.